Okay, guys, we are going to begin Chapter 7, so please notice that we're skipping Chapter 6 for the moment. Not completely, don't worry about that, we'll come back to it. But I want to do Chapter 7 first because it follows nicely from Chapter 5, and it's a nice break from Chapter 5, to be honest. And so we're in Chapter 7, this is Section 1, and we're going to work on solving triangles again. And part of this, depending on your geometry class 2 years ago, part of this will be review. You think, oh, we've done this before, and part of this might be new. We'll have to see as we go through this. But what we're doing in Chapter 7 now is we're going to solve triangles, and hopefully you're thinking, wait, we did that in Chapter 2, SOHCAHTOA, we've solved triangles. Yes, we did, but we only solved right triangles in Chapter 2, and now we're going to solve all triangles. Okay, so the idea here is we're moving beyond right triangles to any triangle. So there does not have to be a 90-degree angle in it anymore. There could be, 40 degrees, 50 degrees, any angle in there that's not 90. And so there's a word for this. These are called oblique triangles. This is a triangle that does not have a right angle in it. Okay, before we get into our law of sines and law of cosines, just one little thing to set the context here. If you remember geometry, you had proofs for congruence. Remember side angle side, or angle side angle, or side side side. And the thing to notice about those is whenever you proved a triangle congruent to another triangle, say one triangle is congruent to another triangle, what happened is you had to have three parts of the triangle. Maybe you had, look, two sides and an angle, one side and two angles. Maybe you had three sides, but you always had three parts, and at least one of those parts had to have been a side. If you had those conditions, you could pin down a triangle and say, this is exactly what it's like. It's congruent to some other triangle. Okay, so we want to remember that as we're doing the law of sines. So if I give you three things, or if the book gives you three things in a triangle, you should be able to find the other three things because three things was enough to pin down a triangle. Okay, second fact is, if you're thinking about SOHCAHTOA, think about it, but realize it only works for right triangles. Our triangles now are not right triangles, so SOHCAHTOA will not be as useful. If you have an oblique triangle, we're going to need something else. What is that something else? Well, it's going to take us 3 sections to actually get everything else. But one thing we're going to need is the law of sines. Go back to that angle, side angle, side angle, side, 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 side. When will the law of sines work? Well, the part we're doing today, it will work when you're given an angle and a side and an angle. And here is the law of sines. It is side A divided by the sine of angle A equals side B divided by the sine of angle B equals side C divided by the sine of angle C. Now, if you've had this in geometry, you might be looking at this thinking, wait, I think he just told me this, the law of sines, I think he just told it to me upside down. You could also have written it sine of A, angle A over side A equals the sine of B over side B equals the sine of C over side C. And we'll actually write it that way in section 2. But it's going to be more convenient today to write it this way. I think for right now I want to stay away from the proof. We can prove that later. I might come back to it and prove it. But I want to really get into the applications first, and we'll come back and look at the proof. The proof is not all that difficult. But for us right now, we're going to focus on the applications. And if we have time at the end, we'll come back and look at the proof, or I can show you the proof in class. So let's accept this right now. A over sine of A, B over sine of B, C over sine of C. And let's focus on the application first. Okay, one thing notice is we're doing triangles. Notice we're in degrees. So your calculator, make sure your mode is set to degrees. Okay, so we look at this and they gave us angle A is 32 degrees, angle B is 81 degrees, and they give us side A is 42.9. So if you sketch this out very, very quickly, here's an angle A and a B and a C. And what did they give us here? Well, they gave us side A, 42.9. They gave us angle A, which is 32, and they gave us angle B, which is 81.8. You might look back at that previous page and say, wait a minute, they didn't give us an angle and a side and an angle. And you're right, when I draw this picture, we don't have an angle and a side and an angle. But it wouldn't be hard, given angle A and given angle B, to get angle C, and then we truly would have an angle and a side and an angle. So this is going to work. We look at it. One kind of key for our law of sines, when do we use the law of sines, because we're going to later contrast it with the law of cosines, is when you have two letters the same, angle A and side A. Typically, that's going to be a law of sines problem. Okay, so we look at our law of sines. I notice here I'm giving angle A, side A, angle B. So I look at our law of sines, and it seems like we'll use the first 2/3 because we have angle A, we have our B's in here, and the C part is not mentioned, so we're going to drop that part of the proportion off. And so I'm going to go with just A, side A over the sine of A, sine of angle A, equals side B over the sine of angle B. And I know side A is 42.9. I can sub that in. I know angle A is 32, so it's the sine of 32. Side B I do not know. And then angle B, sine of 81.8. Look at that. It's a proportion. Proportions are not difficult to solve. How do we solve them? We cross multiply. Come across this way. Come across this way. I'm going to show this in 2 steps. You may be doing this in 1 step. But I've got B times the sine of 32 equals 42.9 times the sine of 81.8. And now I'll divide to get B alone. So B is 42.9 times the sine of 81.8 divided by the sine of 32. Okay, let's pull up our calculator. Let's see what we get for that answer. And again, just double check your mode. Make sure your mode is in degrees. This mode looks like it's in degrees. And now let's try this. Let's go. I've got to raise this just a little bit so it all fits on here. Let's go 42.9. I've got sine 81.8. And I'll divide it by the sine of 32. And before we hit enter, let's just think about this a little bit. What is the bigger angle, angle A or angle B? Clearly angle B is bigger. So clearly side, oops, I lost my calculator. Clearly side B should be bigger. Let's hit enter. Expecting a number bigger than 42.9. Look at that, 80.12. So truly it is bigger. All right, so I just figured out side B. B equals 80, and they're rounding to the tenths, so we'll continue rounding to the tenths. B equals 80.1. And we don't have units on this, so it's just 80.1. Okay, does that make sense? Are we done? No, we're not. We haven't solved the triangle. We've only found one part of it. Let's get angle C. So we have nothing about C. Let's get angle C. I know there's 180 degrees in a triangle, so I'll take 180. I'll take off the 32 from angle A. I'll take off the 81.8 from angle B. And let's see what angle C is. And I certainly could have done that part first. I realize that. But I was so excited to show you that law of sines. And so let's see what we get here. I've got 180. Take off the 32. And take off the 81.8. And angle C is 66.2. Won't say that, we'll just remember that. Angle C, 66.2 degrees. Okay, I need side C. Are you thinking the Pythagorean theorem? Hope not. It's not a right triangle. Pythagorean theorem does not apply. Just like SOHCAHTOA doesn't apply, Pythagorean theorem doesn't apply. So now I will use, over here I had A sine A, B sine B. Now I'm looking for C, so I'll start with my A sine A. But now I'm going to go with C over sine of C. And let's see. Left side is going to look the same, 42.9 over the sine of 32. Here's C, side C, and then the sine of 66.2. Analogous to how we did over here, B, I think you guys can see I'm going to cross multiply. Let me clear that out of here. So we'll go 42.9 sine 66.2 and do the algebra, but we're going to end up dividing by the sine of 32 to get that c by itself. So I cross multiplied, I divided by the second one, and when I do all that, I get side c is 74. Makes sense. It's less than b because angle b is bigger. Makes sense it's bigger than side a because angle a was smaller. So I've got side c is 74.1. And now I figured out all 6 parts of my triangle. Was that 74.1? It was, when we round to the nearest tenth. So 74.1 for angle C. And now I found all 6 parts. I was given 3 parts of the triangle, and I found the other 3. That is our law of sines. Oops, we're going to have a little snafu in here. That'll be okay. Let's put that calculator away, and let's go back to our page here. All right, so 74.2 was angle C. I'll just write that one more time because I got erased. And that is our law of sines. I think we've got time just to start or set up one more, but once you've got the law of sines, they're all pretty much similar. Let's skip. Let's see if there's any. No. Doesn't matter here. Let's go with this one. Look at that. I see 2 letters the same. How would I set this up? Well, are you thinking A over the sine of A equals B over the sine of B? Hopefully. Are you thinking A, we don't know? Sine of angle A is 37. Again, remember, the small letters are the sides, the capital letters are the angles. And then here I've got 14 over the sine of 48. If I cross multiply, I have 14 times the sine of 37 equals A times the sine of 48. Divide it, and I get 14 sine of 37 divided by the sine of 48. That will equal side A. Let's see what we got. Once you get this law of sines down, it goes very, very quickly. So 14 sine of 37. Divide that by sine of 48. And again, angle A is a little bit bigger, isn't it? Oh, sorry, I got that wrong, didn't I? Angle B is a little bit bigger, so side A I expect to be a little bit smaller. And I'm coming up with 11.3. Sure enough, that's less than B. So I've got side A is 11.3. All right, what about angle C? Same process as previous problem. I know there's 180 degrees in a triangle. So C, angle C will take 180, take off A, take off B. Those combined are 85. So it looks like angle C is going to be 95 degrees. Knowing that, can we get now side C? Sure. Let's go this time with B sine of B equals C sine of C. You can't really choose wrong, but since we had that before, let's go with it again. 14 sine of 48 equals side C, I don't know, sine of 95. All right, how do we solve this? You know by now. Cross multiply and divide. Oops, move that out of the way so we can see. So I'm going to go clear this out. 14 sine of 95. And I'm up dividing by the sine of 48. And let's see, angle C is by far the biggest. Side C should be the biggest. And look at that, 18.8 is side C. I guess I should circle or highlight my answers here. There's angle C, I've got side C, and over here that's an A. So side A is 11.3. It never hurts to check. Smallest angle gets the smallest side. Medium angle gets the medium side. Big angle gets the big side. Doesn't prove you're right, but it's a good way to check some mistakes. And so this is the law of sines used to solve for triangles. We did it pretty quickly. You might be a little slower, but certainly you've got the procedure here. So that completes our lesson for today.